हॅलो गाईज, वेलकम टू विज्ञानकट्टा. विज्ञानकट्टाच्या युट्यूब चॅनलवरती सर्वांचं स्वागत आहे. आज आपण होमी भाभा बालवैज्ञानिक स्पर्धा जी आहे इयत्ता 6वी साठीची, त्या होमी भाभा बालवैज्ञानिक स्पर्धेच्या परीक्षेसाठीचा आपण क्लास घेतोय, युट्यूब वरती लाईव्ह घेतोय. ठीक आहे. विज्ञानकट्टाचं हे जे युट्यूब चॅनल आहे, या युट्यूब चॅनलवरती तुम्हाला होमी भाभा परीक्षेसाठी वेलकम टू विज्ञानकट्टा. विज्ञानकट्टाच्या युट्यूब चॅनलवरती सर्वांचं स्वागत आहे. आज आपण होमी भाभा बालवैज्ञानिक स्पर्धा जी आहे इयत्ता 6वी साठीची, त्या होमी भाभा बालवैज्ञानिक होमी भाभा बालवैज्ञानिक स्पर्धेसाठीच तुम्हाला व्हिडिओज याच्यामध्ये खूप सारे दिसतील. ओके. आणि आपण काय करत असतो तर होमी भाभा बालवैज्ञानिक स्पर्धा जी आहे त्या होमी भाभा बालवैज्ञानिक स्पर्धेची तयारी आपल्या फाउंडेशन कोर्सच्या माध्यमातून घेत असतो. आता हा फाउंडेशन कोर्स जो आहे त्याच्याबद्दलची माहिती सुद्धा आधीच्या व्हिडिओज मध्ये तुम्हाला मिळून जाईल. फाउंडेशन कोर्स बेसिकली होमी भाभा बालवैज्ञानिक स्पर्धेच्या तयारीसाठी आहे. त्याच्यानंतर फक्त होमी भाभा बालवैज्ञानिक स्पर्धेसाठी नाही तर NSTS ची जी परीक्षा असते, म्हणजे ज्याला नोबेल सायन्स टॅलेंट सर्च परीक्षा असं म्हणतात, त्या नोबेल सायन्स टॅलेंट सर्च परीक्षेच्या तयारीसाठी सुद्धा हा जो आपला कोर्स आहे हा आपण घेत असतो. ही जी परीक्षा आहे ही नोबेल सायन्स टॅलेंट सर्च परीक्षा साधारणपणे मे महिन्यामध्ये असते, त्याच्यामुळे त्याची तयारी आपण नंतर करत असतो. पण आता ऑक्टोबर महिन्यामध्ये होणारी जी होमी भाभा बालवैज्ञानिक स्पर्धा आहे त्या परीक्षेसाठीची तयारी या फाउंडेशन कोर्सच्या माध्यमातून आपण करत असतो. त्याचबरोबर सायन्स ऑलिम्पियाडच्या परीक्षेसाठी सुद्धा हे जे कोर्स आहे आपला फाउंडेशन कोर्स हा तुम्हाला उपयुक्त ठरत असतो. आजच्या टॉपिक बद्दल आपण बोलणार आहे तो टॉपिक आहे मोशन ऑर टाइप्स ऑफ मोशन, ज्याला आपण म्हणतो की गती आणि गतीचे वेगळे वेगळे प्रकार, याच्याबद्दल आपण आज बघणार आहोत. चला आता आपण सुरुवात करूया. पहिली गोष्ट आपल्याला समजून घ्यावं लागेल की बाबा गती म्हणजे नेमकं काय असतं. व्हॉट इज मीन बाय मोशन. ओके. So to understand that, we will take various examples in our daily life. In day-to-day life, we see many moving objects. Number of objects which we see in our day-to-day lives, they are moving. They are in motion. For example, जर आपण उदाहरण घेतलं, a flying bird, that motion, that object, that bird is in motion. तो गतीमध्ये असतो. Or number of vehicles which we see on road. खूप सारी वाहनं आपण बघतो, ती सगळी गतीमध्ये असतात. These moving objects which are in motion, these are called as objects in motion. The moving objects are called as objects in motion. When an object is in motion, it constantly changes its place. If we observe these things carefully, if we observe the vehicles on road, if we observe the bird which is flying, that object is constantly changing its place. It's constantly changing its place. They are going from one place to another, one place to another. Each and every object, if we observe, which is in motion, which is in motion. Okay. So the objects which is changing its place continuously. Okay. So means what? There is a continuous displacement of that object. म्हणजे या वस्तूचं काय होतंय, सतत विस्थापन होतंय. जागा बदलणं म्हणजे काय तर त्या वस्तूचं विस्थापन होणं. Changing the place is known as displacement. When an object changes its place, we call that displacement of that object occurred. त्या वस्तूचं विस्थापन झालं असं आपण म्हणतो, त्या वस्तूने जागा बदलली असं. मग if the object which is in motion is continuously changing its place, we say that the object is in continuous displacement. Continuous displacement. And the continuous displacement of an object is called motion. So if we have to define motion, how will we define it? We will define it as the continuous displacement of an object, continuous changing the place of an object. If an object is changing its place continuously, we say that the object is in motion. जर एखादी वस्तू सतत आपली जागा बदलत असेल, जर एखाद्या वस्तूचं सतत विस्थापन होत असेल, तर आपण म्हणतो की ती वस्तू गतिमान अवस्थेमध्ये आहे किंवा ती गतीमध्ये आहे. ओके, सो दिस इज अबाउट दी डेफिनेशन ऑफ द मोशन, किंवा याला आपण म्हणतो की केव्हा म्हणायचं की एखादी वस्तू मोशन मध्ये आहे, गतीमध्ये आहे. नाउ द नेक्स्ट पॉइंट इज अ व्हेरी इम्पॉर्टंट. काय आहे की इफ एन ऑब्जेक्ट इज सीन बाय अन ऑब्झर्वर, जर एखाद्या निरीक्षकानं बघितलं, इफ एन ऑब्जेक्ट इज सीन बाय अन ऑब्झर्वर टू चेंज इट्स प्लेस कंटिन्युअसली, जर एखाद्या निरीक्षकानं बघितलं की एखादी वस्तू सतत आपली जागा बदलते आहे, तर म्हटलं जातं की ती वस्तू गतीमध्ये आहे. याच्यामध्ये ऑब्झर्वर इज व्हेरी इम्पॉर्टंट. ऑब्झर्वर इज very important because motion is a observer specific, because motion is a observer specific. If there is observer, then there is meaning to the motion of the object which is seen. अशा कुठल्याही वस्तूला गतीला अर्थ केव्हा प्राप्त होतो, जेव्हा त्या वस्तूला बघणारा कोणीतरी असतो. Suppose we will take an example of a man who is traveling in a train in the direction from west to east. He is traveling in this direction, west to east. When he observed the objects which is outside the train, just like the home or the tree, they are traveling to be in a east to west. The observer observes like the motion of that object when he is moving in a particular direction. He is in motion and he observes how is moving. Same person who will be standing below this tree. Now, what he will observe? He will observe that tree is a stationary. The tree is stationary. जर त्याच व्यक्तीला त्या गाडीमधनं काढला आणि झाडाच्या शेजारी नेऊन उभं केलं, खाली नेऊन उभं केलं, त्याच व्यक्तीला ते झाड आता कसं दिसेल? स्टेडी दिसेल, स्टेशनरी दिसेल, स्थिर दिसेल. बस मधनं बघताना त्याला ते झाड हलताना दिसत होतं. That time that person, the tree was in motion. So the motion observers observe specifically, there is meaning to the motion. Okay. Now we move towards next. Next point is a types of motion. Types of motion is why there are different types of motion. The objects which we see in our daily life, all that objects are, or they are not in a same motion. The motion of wings of birds is a different from the motion of the vehicles on the ground, or the motion of a fan in our house, that is different from the motion of a swing. Okay, so each and every object may have a different kind of motion. So we need to study the different types of motion. We need to study different types of motion, and in these types of motion, the first that we will going to study is the linear motion. पहिला आपण बघूया रेषीय गती. रेषीय गती किंवा linear motion, we can understand the meaning of that word from itself. त्याच्यावरनच आपल्याला त्याचा अर्थ कळतो की what is meant by linear motion. Linear motion means the motion of an object along a straight line. Motion of an object along a straight line. That is called as a linear motion, or त्याला मराठीमध्ये आपण म्हणतो रेषीय गती. Now, in each motion, there is a displacement of object that is happening. We have already studied it. Okay. So in case of linear motion, that linear motion shows displacement along a straight line. Along the straight line. एका सरळ रेषेत जर का वस्तूचं विस्थापन होत असेल तर आपण म्हणतो की ती गती रेषीय गती आहे. If the displacement of an object is happening or occurring along a straight line, then we will say the motion of the object is a linear. For example, bird flying from one tree to another. Bird flying from one tree to another. Bullet fired from a gun. Bullet fired from a gun. That will go in a straight line. That will go in a straight line. Motion on an inclined plane. This girl which is sliding down from an inclined plane, the motion of the girl is a linear motion. Okay. Then again, fruit falling from a tree. The fruit which falls from a tree always falls in a straight line, perpendicular to the surface. Okay. So this is the a uniform motion. Sorry, a linear motion. Linear motion in a line. In a line. Okay. Then again, moving trains. Moving trains. The motion is a linear motion. Then vehicles. Vehicles on a straight road. Vehicles on a straight road. If there is a turn, that's not a linear motion. Okay. So there is a vehicle. Walking man along a straight line. Animals along a straight line. Soldiers on parade. Soldiers on parade. These motion are linear motion. Examples of linear motion. So we need to consider, or we need to study that if there is a displacement of an object along a straight line, whether or not it is uniform, non-uniform, that we will study later. But if an object is moving along a straight line, then we say that the motion of the object is a linear. Okay. And in this linear motion, there are two different subtypes. One is a uniform linear motion and second is a non-uniform linear motion. We will study one by one. Uniform linear motion means what? The motion of an object is a uniform motion along a straight line. Linear means what? Along a straight line. Uniform means what? The speed of that object remains constant. The distance traversed by an object along a straight line in a unit time, if it is continuously same, Distance traveled by an object means what? An object, that means we will take example of these soldiers which are on parade. Okay, so soldiers are parading on a specific direction along a straight line. Okay, they are going from this place to this place in a period of 1 second, and this distance is near about 10 meters. 10 meters. Okay, we will consider it as an example. In the next 1 second, the distance covered is again 10 meter. 1 second time 10 meter distance. In the next 1 second, the distance covered was again 10 meter. In a unit time, the distance covered by an object, if it is same and the motion is a linear motion, then we say that the motion is called as a uniform linear motion. Because here the speed of the object will always remain constant. It is as 10 meter per second. Per second, the distance covered is at 10 meter. In each interval of time. So the speed remains constant. The distance traveled by that object in a unit time, that remains same. So the motion is called as a uniform motion. Example, we will take example of a soldiers on parade. Example of a bullet fired from a gun. These are examples of uniform linear motion. So now we will study another kind of linear motion, that is non-uniform linear motion. याला आपण म्हणतो non-uniform. Non-uniform means what? Which is not uniform. Which is not uniform. And uniform means what? The speed of the object remains constant. So here it is not uniform. Not uniform means what? The speed of the object will not remain constant. Will not remain constant. Means what? The distance traveled by the object along a straight line. It will be along a straight line because it is linear motion. But the distance traveled by that object in unit time keeps on changing. Which is sliding down from an inclined plane. In a first 1 second, the distance traveled by the object will be 10 meters. By the girl was 10 meters. But in the next 1 second, the distance traveled will be 15 meters. In the next 1 second, the distance traveled will be 20 meters. So there will be increase in the distance traveled by the object in a unit time. The time we will taken is a unit time 1 second. But the distance travel at each interval, it is different. So it is changing. First 1 second, the distance travel was 10 meters. In the next 1 second, the distance travel was 15 meters. In the next 1 second, the distance travel was 20 meters. So here, the distance traveled by an object along a straight line in a unit time does not remain constant. It keeps on changing. At the time, we say that the motion of an object is a non-uniform linear motion. Here it is, speed is increasing. In some cases, it may decrease. If we take an example of a vehicle sliding on an inclined plane, जर एखादा चढत्या चढामधनं जर का एखादं व्हेकल चढत असेल, घाट चढतानाची जर का व्हेकल मोशन आपण, it's a non-uniform. The speed is changing. It is decreasing. In this case, it is increasing, whether or not. Okay, no issues. But the speed does not remain constant, and the distance traveled by object in unit time keeps on changing. If that kind of motion is there, we say that the motion is a non-uniform motion. त्याला आपण म्हणतो की ती जी गती आहे ती असमान आहे. हे नॉन युनिफॉर्म जे आहे त्याला म्हणतात असमान एकरेषीय गती. प्रत्येक वेळेस एक रेषीय असेल आणि युनिफॉर्म मोशन असेल तर एक समान एकरेषीय गती. एक समान एकरेषीय गती अशा पद्धतीने आपण त्यांना म्हणतो. त्याच्यानंतर हे झालं लिनियर मोशनच्या बाबतीत. These are about the linear motion. But there are some objects which are not in linear motion. So other type of motion which are not linear one, the displacement of that object is not occurring along a straight line. The motion of an object that does not move in a straight line, that kind of motion is called as a non-linear motion. That kind of motion is called as a non-linear motion. And the first one of its kind is a oscillatory motion. It's a oscillatory motion. What is meant by oscillatory motion? We will just take an example. Example of a girl which is swinging on a swing, or the motion of a pendulum of a clock, the motion of a wings of a bird. All these are examples of oscillatory motion. So what is oscillatory motion? If we observe carefully these examples, we will find that the motion of the object, in this case, they are to and fro motion. The motion of a girl that starts from one point, going to another point, coming back to that point, going to another point, coming back to another point. To and fro motion, or back and forth, or up and down. Any kind of this. वर जाते खाली येते, वर जाते खाली येते, पुढे जाते मागे जाते, पुढे जाते मागे जाते, एका ठिकाणून दुसऱ्या ठिकाणी, दुसऱ्या ठिकाणून पहिल्या ठिकाणी. It's the same kind of motion that is happening, and we will say that motion is a oscillating motion. Now The motion of body that is oscillating, the object which is oscillating, that motion is called as a oscillating motion. Number of examples, as we have studied the example of swing, leaves of plants also. The leaves of plants which swings are according to the air. So that motion is also leaves of. Pendulum of a clock. Needle of a swing machine. Needle of a swing machine. Okay. Needle of a swing machine that goes up, down, up, down, up, down, up, down, up, down, up, down, up, down. That kind of motion is also an example of oscillatory motion. Strings of musical instruments, various kinds of musical instruments, sitar, guitar, or whatever, veena and all the things. The string of that instruments are in a oscillatory motion. If you that plug this string, the string, they will oscillate, and the motion will be oscillating. Pieces of paper dancing on a drum or tabla. Wings of bird, vibrating diaphragm of a tabla. Tabla किंवा ड्रमचा जो काही पडदा असतो. If we start to play that tabla, the diaphragm will vibrate. Diaphragm will have an oscillatory motion. So this is about the first kind of non-linear motion, that is oscillatory motion. Okay. आता हे जे oscillatory motion आहे याला आपण मराठीमध्ये दोलन गती असं म्हणतो. दोलन गती, आणि ही सगळी दोलन गतीची उदाहरणं आहेत. ठीक आहे. अशा पद्धतीनं दोलन गती. त्याच्यानंतर नॉन लिनियर मोशन मध्ये सेकंड मोस्ट एक्झाम्पल, that is circulatory motion. That is circulatory motion. The name itself suggests that motion of an object along a circular path. Motion of an object along a circular path, that kind of motion is called as a circular motion. The example, stone that is swings in a sling. जे आपलं गोफन असतं, त्या गोफणीमध्ये फिरणारा जो दगड असतो, that kind of stone, it has a circulatory motion. Giant wheel, the giant wheel which we see in a fair, जत्रेमध्ये जे आपण बघतो ते, that giant wheel that is having a circular motion. Merry go round. Okay. Hands of a clock. आपल्या घरामधले जे काही hands आहेत, second hand, minute hand, hour hand, all these hands has a circular motion. If we consider any point on that hand, that will have a circular motion. Then fan, the motion of a wings of fan. The motion of a wings of fan, these are examples of circular motion. Then revolution of earth around the sun. Revolution of earth around the sun. Earth around the sun revolves in a specific time. This is 365 days it requires. But that revolution is a kind of motion that is called circulatory motion. The displacement of that object that is happening, that is occurring along a circular path. Along a circular. Then as the same kind, earth, just like earth, the satellite, motion of a satellite along a planet. If we consider example of a moon along, or example of moon around the earth, that is also example of circulatory motion. Motion of a Jupiter along the sun, around the sun, that is also example of circulatory motion. Example of our ocean sat, or whatever example of satellite we take, Kalam sat, or if we take example of the IRNSS satellites which are revolving around Earth, all these satellites revolve along a circular path. Okay. Then example of wind vane which rotates as the direction of the wind. So this is example of a circular. Okay, so all these are examples of circular. Just like linear motion, this circular motion also has uniform circular subtypes, uniform circular motion and non-uniform circular motion. Just like that, same way, uniform means what? The speed of the object remains constant. We call it as a uniform. And non-uniform, the speed of that object changes continuously. Means if there is a speed of an object in a circular motion, if the speed remains constant, we say that the motion of the object is a uniform circular motion. But if speed is changing, then we say that it is non-uniform. It is non-uniform circular motion. Now we are studying about the circular motion. So here also two different kinds of subtypes of this circular motion: uniform circular motion and non-uniform circular motion. Then the next point we will study is the periodic motion. Periodic motion means what? Motion of an object, okay, that completes one round or one oscillation in a fixed period of time. In circular motion or in oscillatory motion, if we take some examples, we will find that there are certain objects which are in circular motion or in oscillatory motion. They complete their one round or one oscillation in a fixed period. In a fixed period. If we take example of our minute hand of a clock, that complete one round in a exactly 60 minutes every time it completes its one round in a 60 minutes. I have just stated the example of Earth, which revolves around the sun in a exactly 365 by 1/4 days. 365 into 1 by 4 days. 65 plus 1 by 4 days. So 365 days, if we consider it, that's a complete round. And each and every time it will complete its one round in a 365 days. So these kind of motion are called as a periodic motion. This kind of motion is a periodic motion. So example of minute hand of a clock. So example of second hand of a clock. So example of hour hand of the clock. Hour hand of a clock will complete one round in a 12 hours. A second hand will complete in a one minute. But they are completing their one round in uniform time, in a fixed period of time. So that kind of motion is called as a periodic motion. Again, example of merry-go-round. Merry-go-round also completes every round in the same period of time. Motion of an object which passes through a certain point. If we consider a point on that path, whether it is circulatory, whether it is oscillatory, whether it is one. If we consider a point on the path, and if the object which passes through that point again and again after a fixed period, if that girl which is on a bicycle and is traveling on a path, okay, that path is just like an 8. If we consider this point and the girl is passing from this point in a fixed period, after a fixed period of time, we say that the motion of the girl is a periodic motion. Fixed period of time is called as a periodic motion. So motion of object, just like Earth, motion of minute hand, second hand, all these are example of periodic motion. Again, there are some other kind. Just like we cannot decide what will be the next motion, or what will be the position of object after a period of time. If motion is uniform, if motion is non-uniform, we can decide by using equations and by finding the laws of motion and all that things. But the motion of object is a random motion. If the motion of an object is random motion, means what? The objects moving in any direction with any speed, that kind of motion is called as a random motion. Means what? Example of dust particles. We cannot decide whether the particle will be in this place, will be in this place, will be in this place, will be in this. After 1 second, we cannot decide it because direction is continuously changing. Shows random motion. Pollen grains, flying insects we cannot decide. Kite, smoke, air, gases, all these are example of random motion. Okay. So, and the next motion is a compound motion. Compound motion means what? When an object has more than one kind of motion at the same time. More than one kind of motion. Means if we take example of a pencil which rolls on a table, that pencil will have first linear motion, because it is rolling, but it is going from one place to another in a straight line. So the motion of the pencil will be linear motion. The second, it is rolling. It is rolling. So the motion is a circular motion. At the same time, that pencil having circular as well as linear motion. That kind of motion is called as a compound motion. Or example of moving wheel. Moving wheel. Moving wheel, that moving wheel, again the same kind of motion. Circular motion, because that wheel is rotating, 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 rotating. And it is also traveling from one place to another place on a linear path. So that kind of motion. When an object is having more than one kind of motion at the same time, whether it is circular, whether it is linear, but more than one kind of motion at the same time, we say that the object has a compound motion. The object has a compound motion. Now, if we have to measure this motion, if we have to measure motion of an object, yeah, it is in motion, no doubt. But how can we measure it? So we can measure it by using speed of the object. By using speed of the object. And what is meant by speed? The distance covered per unit time. The distance traveled by an object per unit time is called as the speed of the object. The speed of the object. So the formula for the speed becomes speed is equal to distance divided by time. Distance divided by time. Okay. So distance divided by time. This is the formula. And the unit of that speed becomes MKS system, means meter kilogram second system. MKS system, it's a system of measurement. We have studied it in a units and measurement topic. Okay. So this MKS unit of the speed becomes meter per second, because distance is measured in meter and time is measured in second. So MKS unit of speed is a meter per second. And CGS unit of speed becomes centimeter per second, because in this CGS system, the distance is measured in centimeters. Time is measured in second. So the unit becomes centimeter per second. Okay. Now we will study, as just we have studied about the speed, we will study another kind of a physical quantity that is called as a velocity, which is also used to measure the motion of an. But there is a small difference between speed and velocity. Whether if we study the units of velocity in MKS system, it is also meter per second. In CGS system, velocity is also centimeter per second. If units are same, speed and velocity are the same units, but there is a small difference between the definition between the formula. The speed is equal to distance divided by time, but the velocity is equal to displacement divided by time. Velocity is equal to displacement divided. Displacement, it was change in place of an object. Change in place of object is called as a displacement. But displacement is a vector quantity. Displacement is a vector quantity. It has direction. So the value of displacement is different from the distance when the motion is a non-linear motion. When the motion is a non-linear motion. Okay. If the motion is a linear motion, then the value of speed and velocity will be equal. But if motion is a non-linear motion, then value of speed, the value of velocity is different, because the value of distance and the value of displacement different in non-linear motion. But the units become same, as distance and displacement both are measured in meter and centimeters. Both are measured in as a length. So the units are same, but the definition is different, the formula is different, and the concept is also different. Okay, so this is about if we measure a distance, if we measure the speed of a maglev train, that's a fastest train. The motion is a 600 kilometer per hour. 600 kilometer per hour. Here the speed is given in or the velocity is given in a kilometer per hour. Kilometer per hour. if we need to convert that into meter per second, if we convert that into meter per second, how we will convert that? By using a formula that 1 kilometer per hour is equal to 5 by 18 meter per second. 1 kilometer per hour. Now, if we consider this, so we will multiply that 600 into 5 by 18. 5 by 18. 18, 3 and 6, 1. 100 into 5, 500 divided by 3. That will be the value. In meter per second. In meter per second. Okay, so we need to convert that units into kilogram per hour to meter per second. So we can convert it by using this formula. So this is about the speed and velocity of an object. Okay, so now I think most of the points regarding that speed, velocity, distance, displacement, again motion, different types of motions are covered in this topic. Okay, so in the next class we will study a different point, a different topic. Okay, and we will meet again in the next Sunday at the same time on our YouTube channel. Bye bye. Good night.